Welcome to the seventh and final session of the 2023 National Weather Service Milwaukee Sullivan Storm Spotter training. For this session, we're going to talk about the different types of severe weather that you can report to our office. So with flooding, this one's pretty easy. If you see a road, you can report on whether or not it's closed or open if the water's going over the top of it. Some of the things you can talk about are whether or not it's flowing or just standing there. Some of the things that have helped in some of our bigger flooding events has been things like it's never reached this area before, this is not normally flooded, things like that helps us with understanding how bad it is. Otherwise, just having a rain gauge to be able to measure and report on how much water fell or how much rain fell would be helpful to get that information as well. For hail, measuring this is pretty easy. Reporting on this is just taking a ruler and grabbing whatever the biggest hailstones were and measuring that. You can take a picture and share that with us as well. That's an easy way to be able to report to us. If you don't have a ruler, you can use a quarter or some of these other different objects here to be able to report on how big the hailstones were. Having a quarter to compare to is a good one because it's our severe limit. So if you go to that and the hailstone is bigger than it, then you know it's severe. Straight line winds, damaging winds. This is a little bit more of a tricky situation because most people tend to overestimate how strong the winds are. When you have tree damage like this, just tell us what you're seeing with the actual damage. So this is a whole forest here that's been toothpicked like that. It's not just one or two trees. Those are healthy trees there. So that's where you start getting some of the higher end type winds. When it comes to trees like this, where the shallow roots are there, um, the big trees are a little bit easier to blow down. So if they get wet and the wind hits it right, if it's got shallow roots, it's going to be easy to knock that over. So depending on the situation, we might assess the winds at a different level. But for you, you can estimate the winds. It's hard. Most people tend to overestimate how strong those winds are. But in this situation here, here's a couple examples. So 30 to 40 mile per hour winds. A lot of people tend to overestimate and say that these are some extremely strong winds, maybe like 70 miles per hour, but it just looks intense because you've gone from maybe having calm to light winds and all of a sudden you've got this big thunderstorm rolling in. Just look to see what kind of damage there is or how what kind of tree motion you're seeing from those storms. Try to use for the 40 to 50 mile per hour winds, you're maybe starting to see some more in the way of like twigs breaking and small branches as well. Again, it's every situation is a little bit different with how strong these tree branches are. So just try to estimate based on what you're seeing with the damage and what occurred and what came through. When you start getting into 50 to 58 mile per hour range, you start seeing more significant damage. This is on the threshold of our what we consider something to be a severe thunderstorm or 58 mile per hour and higher. So you see things like this where limbs are breaking and there's more widespread type tree damage that's occurring as well. When you get to 58 to 75, more widespread type wind damage, and you're starting to get bigger parts of the trees getting knocked out. With houses or any kind of structures, typically it might just be some shingle damage that you're seeing from the wind blowing across that, typically up towards the top by the crest of the house. In the highest end, the 75 mile per hour higher, that's when you start seeing structural damage like this to the top part of the house. Very rare that that happens, but it can. Otherwise, trees uprooted, trunks snapped, things like that. So with the wind, just know that it's hard. There can be, different things that get blown around, like patio furniture, things like that. But it might not necessarily mean that that's a severe thunderstorm wind. Again, if you don't have anything to mark it to as well, that can be difficult. But this was a video from Racine where they had 60 mile per hour winds that were measured there. So again, how to report this damage? Just tell us what you're seeing. You can estimate how strong you think the winds are. But then maybe follow up with whatever kind of tree damage you're seeing. Just instead of just saying trees down everywhere, tell us what parts of the tree or how many, what the diameter of the tree branches were, things like that. Structural damage, again, pictures are pretty easy with this. This can help us help guide us for where we need to go on damage surveys if you have a specific location for where the wind might have done damage to a building. But if it's a tree that fell on the building, that's different. So again, just tell us what you're seeing, and that helps us to document what happened with this storm. This one here, this was where we had wind-driven hail into the side of the house. So the report was numerous dents in siding due to the hail. That's a very descriptive measure there. 12-foot giant skeleton decoration topple. So that's an accurate depiction of what happened there. We had those tornadoes that came through last October, which knocked over some decorations, it looks like here. Roof damage with a few rows of shingles torn off. So again, just describing what you're seeing from that situation and not over exaggerating. We've had people with house damage like this where like, oh, it's obliterated, or it's, just tell us what you're seeing. Don't over exaggerate. And then this one here, the garage door blown in and the roof was peeled off. That's just saying exactly what's happening there. So when it comes to different types of wall clouds, so these features that are in the southern part of the storm that are used to look at where potential tornado development would be. The wall clouds are this isolated lowering. It's this cloud that hangs down in that updraft area of the thunderstorm. And it's this isolated lowering as opposed to the shelf cloud, which is the long cloud on the horizon pushing out away from where that thunderstorm is. These have many different looks to them. There's kind of a trick that I use where I look at the cloud on the left-hand side and just see if it's moving from left to right and how fast that's moving as well to gauge how strong that rotation is. So there's a lot of different good pictures of wall clouds out there. You can see there's different shapes and sizes to them. Just because we have a wall cloud doesn't mean you're going to get a tornado out of it. It depends on the environmental conditions as well. We had a lot of wall clouds last 4th of July, and none of them produced a tornado, thankfully. But just know that they're each a little bit different. As I mentioned, make sure you know the difference between a shelf cloud and a wall cloud. So when you have this long cloud along the horizon, that's a shelf cloud. That's marking that change in the wind speeds. The wall cloud here is this isolated lowering on the southwestern side of the thunderstorm. With funnel clouds, this is a rotating column of air that is not touching the ground. So to compare this to a tornado, the tornado is in contact with the ground. There's debris getting lofted from that cloud. So the main thing to do is just watch to look for that rotation. There's some clouds called scud clouds, which can look like funnel clouds, but they are not. Just have the same look, but just aren't rotating. So again, as mentioned, the difference between tornadoes or funnel clouds, is it in contact with the ground? Is the wind field from that rotation making it to the ground or not? If it is, it's considered to be a tornado. If it's not, it's considered to be a funnel cloud. Water spouts, these are only over Lake Michigan, so you can watch for spray at the base of this. If you do sit along the Lake Michigan shoreline, you can see these and report them to us, and that helps with us issuing special marine warnings as well. So the definition of a tornado is a rotating column of air that's in contact with the ground. So when you're seeing something like this and you have a report that you want to make for tornadoes, just tell us what you're seeing and how confident it is in what you're seeing. So this was a really good report we got from Dan Greinke from Beloit from last year. We got a tornado here, and he reported there to be rain obscuring the view a little bit, and you got a tree line here, but also some debris. You see that debris getting kicked up there. You could tell us exactly just what you're seeing there with that storm. So again, call us if you are looking at this tornado. That's the fastest way to be able to get us any kind of information when it comes to these tornadoes. We don't want to wait on them and have a back and forth on Twitter trying to gather information. Call us first, and then if you want to provide that information online, you can do that afterwards to show what you're seeing. But calling is best, and we can ask you some questions about what you're seeing. Some things you don't have to report. If you're getting secondhand or unconfirmed reports, don't just play the relay game, because sometimes people can exaggerate what's going on out there. Lightning and thunder, we get a lot of reports of heavy thunder. We have ways to be able to see the lightning on our displays at the office, so no need to report to us that you're getting lightning or thunder. Light the amount of rainfall, that's where Kokoraz is best. Having the rain gauge and being able to measure that, and just reporting it once in the morning around 7 o'clock, you can do that. And then the shelf clouds, as we talked about a little bit, no need to report those as well. We can see these, they look really cool, but we can't gauge how strong the winds are when we're looking at a cloud like this. So it looks pretty ominous. You can take a look at it and take pictures of it, but no need to share that with us or um, report it to us that you're seeing a shelf cloud, because our assumption is that there's going to be one with it when we get into these situations where there's a squall line or something like that, where you would see something like this. Scud clouds or the scary looking clouds, again, just look at what's happening with the clouds dangling underneath the thunderstorm. Are they rotating, or are they just kind of dangling there, just getting slowly pulled up into the thunderstorm? If they're not rotating and there's just the movement where they're going up into the cloud, that's where um, you can just, you don't need to report that as a funnel cloud. Just know that, hey, what I'm looking at here is not a tornado. It might look a little bit ominous or scary, but it's not a tornado. We've had some other lookalikes been called in as a tornado or funnel cloud. The rain shafts here is this isolated band of rain that looks pretty ominous, but again, if you watch it for any amount of time, you'd see that there's no rotation there. It's just this the rain that's coming through. And then Virga, this is just rain that's drying up before it gets to the ground, so not a funnel cloud there. So to finish up everything, just the overview. The number one rule of storm spotting is just being safe. We don't want anybody getting injured or hurt from doing this. So if you don't feel safe, just stay home and ride out the storm and be ready to jump in the shelter if something bad's coming your way. Having a lot of ways to get information is important. Knowing whether or not today is going to be a day where you have to go out and storm spot, and then just all the different things that come with storm spotting, what kind of things you need to do to be safe, being on that southern side of the storm looking northwestward, having a safe escape route to get back home, knowing how long it's going to be. And then the who, what, when, where is very important as well. So with that, the thing to know is that most storm spotters come back every 2 to 4 years for the storm spotting. You can take a refresher class every 2 to 4 years, or you can watch these videos online as well. We have a lot of different resources on this website. If you have questions or comments, you can email me at the email address listed there. Otherwise, just want to say thank you and appreciate all the future reports.